Hello and welcome back to Data Analysis and Visualization. I'm Jivita Christie, and in this video we are going to talk about sampling and we're going to introduce probability. So let's begin. First of all, what exactly is sampling? A sample is something that you take out of the entire population, and this is something that I explained when I began with these lectures, that you cannot really analyze the entire population. You would have to take a sample from there and analyze the sample in order to be able to understand the population. So a sample could be a biased sample or an unbiased sample. You would definitely want an unbiased sample to be able to perform a good analysis. So what is a biased sample? A sample that produces data that is not representative because of the systematic under or overestimation of the values of the variable of interest is called biased. So if you are trying to analyze opinions of different students about whether or not there should be exams, whether the exams should be taken online or they should be taken in person. So if you are analyzing such opinions, but you are only going to an institute that is taking exams online all the time, and you're only asking these students, then your sample will definitely be biased because these students are more likely to prefer the online method since they are already using it. So if you have bias in your sample, then it can result because of a poor sampling plan. You did not decide on the plan properly, and that's why there's a bias. Or it could result from a poor design for evaluating the variable of interest. So these are the reasons why sampling is very important, and we are going to see how you can do sampling, what are the different types of methods to do that. The first method is a simple random sampling. A simple random sampling is, just as the name suggests, the simplest sampling plan. This is equivalent to selecting names out of a hat, or just tossing some sort of a coin, or doing any random activity. It's a simple random sample. So here every individual has the same chance of being selected. So if I just go to a crowded place and pick one person, then every person in that crowded place has the same chance of being picked. So that is simple random sampling. The next type of sampling we have is a cluster sampling. So in this technique, your population would be already naturally divided into groups, which we would be calling clusters. And that's why what you will do is take random samples of clusters and then use all the individuals within the selected clusters as a sample. Let me tell you that with an example. So in a cluster sampling, you would suppose if you wanted a sample of students, a sample of high school students from a certain city, then you would first of all go to that city and select 3 high schools at random. Then from among those 3 high schools, you would from among all the high schools, you would select 3 high schools and then use the students of those high schools, the 3 selected high schools, as your sample. So that is how simple cluster sampling is. The next type of sampling we have is a stratified sampling. So a stratified sampling is used when the population is naturally divided into subpopulations, which is known as a stratum, and the plural of that is strata. So an example of this is when all students in a certain college are divided by gender or are divided by year in the college. So this is a strata, this is not a cluster. So there's a difference between a cluster and a stratum. Now, how would you do the sampling? So to do the sampling process, first of all, you would choose a simple random sample from each stratum. So if you are analyzing college students, then they are divided into, let's say, 4 years. Then you would choose some students by using simple random sampling from each of the years. And now your sample consists of all the simple random samples put together. So you just combine all the students that you selected and put them together. That is your sample. Let's take an example. So to get a random sample of high school students from a certain city, you would choose, first of all, a random sample of 25 students from each of the high schools in that city. And then you'd combine all those 25 students to create your whole sample. So this is stratified sampling. And now I'm going to introduce to you the concept of probability. We are definitely going to be covering probability in the next video. We'll understand all the technical formal definitions of probability in the next video. But in this video, I would like to introduce you to the concept of probability, what it is, and how it has been used since ages. So this is a game. What you see on your screen right now is a game which was known as Let's Make a Deal, which was coming on the television in the 1960s, a long time ago. But this is a very good example to understand how probability actually works. So the game is something like this. You have 3 doors and you need to find out this was an actual television game, so there were people playing it, and there would be a host that would be hosting the game, and he would call somebody up over on the stage. That person would go there, and the rules of the game are very simple. There are 3 doors, and the person has to pick one of the doors, one of the 3 doors. Now, behind one of the doors, there's a very nice gift. Okay, there's something very nice, very attractive, a good gift behind one of the 3 doors, but only behind one of the 3 doors. The other 2 doors do not have anything. So that was the game, and the person has to just come and choose one of the 3 doors. But then there's a little twist. If suppose you selected the first door, then just to confuse you, the host would open one of the doors of his choice. So the host would just open one of the doors of his choice, and then he would ask you whether you still want to. Of course, that wouldn't be the door that you selected. So the door you selected is not going to be the door that is opened. One of the other 2 doors will be opened, and then the host would ask you, after opening that door, if you wanted to still stick to the door that you have selected, or you wanted to switch to another door, switch to the other door that is not opened yet. So that is how the game works. And it's all about probability, if you understood. Now the question here is, in this game, whether to stick to the door that you have selected or to switch, which one's better. So that's what we are going to find out now with this simple example that I'm showing right here. So consider that you have 3 doors here, A, B, and C. And the probability that the gift is behind A is 1/3. Probability of B is 1/3, C is 1/3. Suppose you selected door A with a probability of 1/3. Now that means the doors that are left are B and C. Together their probability is 2/3. So probability of gift behind A is 1/3 and behind B and C is 2/3. Now assume the host selected door C and opened door C, and there is no prize behind door C. So you are left with now door A and B. Should you switch or should you remain with A? So because C is gone, now the probability of the gift being behind B is 2/3, so it's actually more, which means you should actually switch to B. That is the more appropriate choice because A is having a probability of only 1/3, right? So probability of the prize being behind B is 2/3 since C has been opened and there was no prize there. So it's a question of whether to stay with the door A or to switch to B. We are not saying that if you switch to B, you are definitely going to get the prize, but your probability of getting the prize will definitely increase if you switched to door B. Whereas if you stayed with A, then the probability is only 1/3, and that's why your chances of getting the prize are less if you stick to A. So this example is just taken to make you understand that probability is not intuitive. It is a mathematics, it's a science that you calculate, right? And if you calculated, you wouldn't go with your intuition and decide whether to be with A or to be with B, but rather you would make a calculation and understand that going to B would be a better choice. Now, what we're going to do is take a look at this example once again with a slightly different approach. So in this approach, once again, you have three doors, A, B, and C. Now, in these three doors, you have three cases. Case 1 is where the prize is behind door C, mentioned by the dollar sign. Case 2 behind door B, and case 3 behind door A. So wherever dollar sign is there, that is where the prize is. There are three cases possible. Now assume that you picked door A. So let's discuss case 1. What happens in case 1? You picked A, but the prize is in C. Now imagine that the host obviously opened door B because there's no prize. Now, is it better to switch or to stay at A? Obviously, switch. Case 2. Now suppose you picked door A, but the prize is at B. The host will definitely open door C. Should you switch or stick to A? Obviously, you should switch. Now, case 3, the prize is behind door A. So the host can actually open either B or C in this case. So this is the only case where you should actually stay with the door that you selected and not switch. So what do you understand by this entire explanation, by this approach? Is it better to stay on the door that you have, or is it better to switch? Just take a minute and try to understand whether you should switch or you should stay with what you have. So you could pause the video right here, take a minute and think about what you should do here. The thing is, if you have these types of cases, you can see that out of the three cases, two cases are saying that you should switch, right? Only one case is saying that you shouldn't switch. So what should you actually do? You should definitely switch because there are two cases. There's a higher probability of you getting the prize if you switched. There's only one out of those three cases where the door you picked contains the prize. So if you were thinking in the terms of probability, you would probably switch. Now, the reason why a lot of people don't get this is because suppose you picked door A and then the host opened door B and there was no prize, of course, behind door B. And he's asking you whether you want to switch from A to C or not. So at this point, people start thinking that door A and C both have a 50-50 chance of having the prize. So they think that the probability of the prize being behind A is 0.5 and probability of the prize being behind C is also 0.5 or 50%, right? But that is not true. The probability of the prize being behind C is 2/3 and behind A is only 1/3 because of the two approaches that we saw earlier. So this is what probability is all about. And We are going to understand this in much more detail in the coming lecture videos. So I'll be seeing you there, and thank you for watching.